So in this bag is a bunch of sticks, like that. Loads of them is in there. Now, the problem is I don't know how many sticks there are in there, and it's a bit too mainstream to just pour it all out and count it. So I'm going to try to estimate how many sticks there are in there, and I'm going to show you how I'll do it. Alright, so the first step is I have to take out some number of sticks. Don't have to be all of it, so I'm going to grab a handful of basically. Right, that's a handful. Let's see how many I grabbed. I grabbed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So grabbed 14 sticks out of the bag. Now what I'm going to do is I'm going to take a pencil and I'm going to put an X right in the middle of it, so it looks a bit like this, right? So I'm going to have an X right on the middle of the stick. You can't really see that. Really, the color doesn't matter. I just don't have like enough sticks of the same color, so I'll put an X like this in all of the samples that I just picked out. I'm kind of doing this live, so I don't know how this will turn out. I actually haven't counted the matchsticks, and I am just making this video as I go along. So this could turn out badly if I do something wrong, but let's hope it doesn't. So all the sticks now that I picked out has got some kind of an X on it. Every one of them has got a little X, as you can see right there. And now I'm going to put this all right back into the bag like that. So now I'm going to have to let these mix properly. So I'm going to influence it a bit by shaking it. Right, so now I have properly shaped this thing, and yeah, I'm now going to pick some samples of this thing again like I did earlier. So I'll just put my hand in and grab out a handful again. Oops. Right, how many did I grab this time? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. I grabbed 12 of the sticks out. And I'm also going to count how many of these I have X's on. This one doesn't. This one has got an X on it. This one doesn't. This one doesn't. This one has got an X on it. 3 of them now. Not this one. 4 of them's got an X on it. This one doesn't. And turns out that 4 of them has got X's on it. So now let's make a bit of a table. I've grabbed out of the bag 12 sticks just now, and 4 of them has got X's on it. So, right, let's put that in the table. Now I also knew that earlier I put 14 sticks that had X's on it, so I can also add that to the table. Now look at the bottom row. There is 4 sticks in there that has got a mark on it out of the 12 of them. So that means the ratio between the marked sticks against all the sticks that's marked or not marked in the sample would equal to 4 divided by 12. And because this sample is a sample of the whole population of sticks that's in the bag, you can kind of assume that this ratio will also apply to the main kind of bag, how many things are going to be in the bag. Now, when we picked out the 12 samples, if you want to know how many of that sample there's going to be an X on it, you multiply that number of sticks you picked, 12, and you times that by the ratio, which is 4 over 12, which gives you 4. So if you want to go from how many sticks you have marked to the total number of sticks you picked out, instead of multiplying by the ratio like we did earlier, we divide it by the ratio. If you want to go from the 4 to the 12, you have to divide it by 4 divided by 12. So if in the bottom row you know how many marked sticks you have, and you can multiply it by the ratio to get the number of sticks that you picked out, marked or unmarked, you can probably do that with the total number of sticks that you have, because you know how many sticks are marked. You marked it yourself. We marked it ourselves earlier. There's 14 of them. So if you divide that by the ratio, we should probably get a good estimate of how many sticks there are in the bag. So if you work out this math, you'll find that the total number of sticks that's in the bag would equal to how many marked sticks you put in the bag originally, which is 14, divided by the ratio, which is 4/12. So 14 divided by 4/12, or 14 times 12 divided by 4, which comes out to about 56 sticks. And so that's kind of my estimate. There's probably about 56 of these lollipop sticks, or whatever you call them, in the bag. So why would you ever do this to find how many ice cream sticks there are in a bag? Well, the truth is, you don't. You don't actually do this. I just use this example to make it easier for demonstration purposes. This method that I just demonstrated, which by the way is a name called the mark-release-recapture method, is actually used in something else. It's actually used in the field of biology to count the population of a certain animal species, moving animals, in a given area. Now, you know, because animals aren't still, they aren't like plants, which you can just simply count, and even if plants, you wouldn't really want to count individual plants, but animals move, so you can't really just count 1, 2, 3, 4, 5, because maybe some of them goes hide behind the rocks, or maybe some of them moves from there, and then moves to the other place, and then you end up counting them twice, and then you cause this chaos. So it's not the best way to just simply count it. This is why you use this type of estimate. So maybe, for example, just pure example, I want to count how many beetles there are in a certain area. What I can do is I can gather some number of beetles, capture it somehow, and then maybe put a spots of white paint onto the Now, after you've done that, you can release the beetles back into the wild, let it mix with the other population of beetles for maybe, you know, some number of time, maybe a week, maybe a month, whatever. And then after that number of time, you recapture another sample of beetles, similar to when we re-grab another bunch of sticks out. You can recapture some more beetles and then count how many marked beetles there are against how many beetles you captured, and then use very simple mathematics, similar to what we did, to work out how many beetles there are approximately in the area. Of course, if you want a more accurate answer, you would have to repeat your experiment, or maybe a larger sample, maybe mark a bit more, something like that. But again, there's also other factors, because this number you made is kind of an assumption. It's not definite, it's not exact, you know, because maybe the beetles might have not mixed together that well. Maybe some of the beetles you marked got killed, maybe it fell off the cliff, or maybe it got eaten by a beetle eater, whatever animal eats these beetles. Maybe it gets isolated from the other beetles because they see you have a white dot on your bum and then say, no, I don't want to deal with you, something like that. Maybe the beetles paint that you put on got washed away, or maybe it's toxic to the beetles and the beetle died, although this shouldn't be a problem because you should really be using a non-toxic waterproof paint anyways to kind of make the results more reliable, to make sure that the results doesn't really get affected by the color or anything. But it's all just assumptions, because we can't be definite with these figures about how many beetles there would be. It's just kind of a rough estimate, which is obviously better than just counting how many beetles there are, because there might be thousands of them, and that's going to be quite tricky. I hope you enjoyed this video, and I'll see you again soon. Goodbye. Guys, I just counted, and it turns out there was actually only 50 sticks in the bag, which shows that I'm not actually that far off.